The Hinge Joint 2D is a 2D component that allows a sprite to rotate around a point while being controlled by 2D rigid body physics. The most obvious use of a hinge joint is to rotate a sprite around a point to make a door. But there are many other uses of the 2D hinge joint, including machine parts, pendulums, and spring-loaded trapdoors. A group of sprites with 2D hinge joint components attached can work together to make a chain. At the heart of the hinge joint 2D is the point which the sprite will rotate around. This is either a point in the scene, or another sprite with a 2D rigid body attached. This point is determined by the connected rigid body and the two anchor properties. To connect the hinge joint 2D to the world, or a point in the scene, leave the connected rigid body property empty. To connect the 2D hinge joint to another sprite, the other sprite must have a rigid body 2D attached. A reference to this rigid body 2D needs to be made. One way of doing this is to drag the desired sprite with the rigid body 2D attached onto the connected rigid body slot in the inspector. To define the exact position of the pivot point, the properties of anchor and connected anchor need to be set. These two properties are needed to define a single pivot point. The first property, anchor, is the point the sprite rotates around, relative to the sprite in local space. This point does not need to be within the bounds of the sprite. The second property, connected anchor, is where in the scene this point is placed. And this point is relative to the connected item. When connected to the world in the scene, these values are in world space. When connected to another 2D rigid body, these values are in the connected body's local space. When rotating around another sprite, it is important to note the Collide Connected checkbox. With Collide Connected unselected, the sprite will ignore collisions with the connected sprite. To collide with the other sprite, make sure the Collide Connected is selected. The Use Motor and Use Limits are special properties for the hinge joint. The hinge joint can be actively powered by a motor. When Use Motor is selected, the hinge joint 2D will apply torque and rotate the sprite. Motor speed is the target speed in degrees per second the motor will try to reach. Maximum motor force is the maximum torque the motor can apply while attempting to reach this target speed. When Use Limits is selected, the 2D hinge joint will be prevented from making a full rotation. Lower angle is the lower end of the rotation allowed by the limit. Upper angle is the upper end of the rotation allowed by the limit. Note the gizmo indicating the angle limit of the joint in the scene view. Motors and limits can be used together to create new and interesting behavior. One use would be to make a spring-loaded trapdoor. Use limits to prevent the trapdoor from moving too far, and use the motor to return the trapdoor to its starting position. A series of hinge joints can be used to make a chain. In this example, a kinematic platform is the base sprite, to which is attached a series of sprites, each with rigid body 2D components to make the links. Each link is connected to the link above with the hinge joint 2D. Note the Collide Connected is deselected. At the bottom is the 16-ton weight. Unlike the links, the mass, linear drag, and angular drag have been increased to give the weight a proper feel in the scene. It is worth noting that a distance joint 2D with max distance only enabled has been added to the weight to limit the maximum distance of the weight from the base link, and to make the chain perform more realistically. For more information on the distance joint 2D, please see the information linked below.